Right, everyone's favorite, let's look at a story problem here. A doctor may use a beam of gamma rays to treat a tumor that is 5.7 centimeters beneath the patient's skin. To avoid damaging a vital organ, the radiologist moves the source over 8.3 centimeters. All right, so we've got this tumor. All right, I'm just going to kind of draw in a ugly looking thing there. And then we got this vital organ. Let's call it the heart. It's pretty vital. All right, so obviously I don't want to hit my ray straight down there. I don't want to affect the heart. So my skin's up here too, right? Put some hair on the skin. So we can't put it right here, otherwise it's going to hurt the heart. So we need to do more of a angle at attacking that tumor. And we need to figure out what is that angle. Okay, so we know it told me the tumor here itself, straight down from the skin, is 5.7 centimeters. And it also tells me that I moved my source over 8.3 centimeters. So I need to go ahead and find that angle. So you ask yourself, what are my sides? Well, this side is the opposite side. And this side is my adjacent side. And if I'm dealing with opposite and adjacent, I know I'm dealing with tan. And I'll just call it theta. So tan theta is equal to my opposite side, which is 5.7, over my adjacent side, which is 8.3. And now I solve for theta by running to my calculator and typing in inverse tangent of 5.3 divided by, 5.7 divided by 8.3. Hit enter, and I get 34.4, the nearest degree. Yeah, 34. So we're just going to say 34 degrees. However, if I was messing with array, I bet you they need to be a little closer than a degree. So they probably want some more decimals there. But we'll follow directions. Next question asks us, well, how long is the beam? Right? So this is the exact same story problem. It just says, how far will the beam travel through the patient's body before reaching the tumor? So again, remember, I've got the hairy arm, I've got the heart, I got the ugly tumor, and I know this is 5.7, this is 8.3. I'm looking, and I found that this was 34 degrees, and I'm looking for that length right there. There's multiple ways to do this. Some of you might be saying, oh, I know how to do this from Algebra 2. And that's fine, because you have the handy-dandy Pythagorean theorem. So I can do 5.7 squared plus 8.3 squared equals x squared. And then just go to my calculator and solve that. 5.7 squared plus 8.3 squared. Hit enter, and then we need to take the square root. Oops. Square root my answer, and I get 10.069, we'll say. And I just want to be that accurate so that I show you how to do it with trig. I also could use any of the trig functions I want, right? Because if I use cosine, right, I could write cosine of 34 degrees equals 8.3 over x. And if I do sine, I would use, instead of the 8.3, I'd use 5.7 over x. Now here's the problem is, because 34 I've rounded, these are going to be slightly off. So you probably don't want to round in your calculator. So when you did the inverse tangent, you use that angle. So if I do inverse, I'm looking for x value, so all I'm going to do is take 8.3 and divide it by cosine of 34. cosine, I'm going to do 34.5 just to get a little bit more accurate. 8.3 divided by cosine of 34.5. You can see that's pretty close, 10.07. Remember that 34 went on forever. And if I do sine, I do 5.7 divided by sine of 34.5. And again, you get pretty close to the same answer as well, keeping in mind we rounded. So hopefully that helps. You can do it any of the ways. No one's going to mark you off for doing the Pythagorean theorem versus doing the trig, just so you know how to use all of them. All right, so why don't you stop now, try the on your own, and we will go through these in class tomorrow. Have a nice night.